Hello, and welcome to the Science to Sleep channel. I'm glad our paths crossed in this video tonight. You've probably had a long day behind you, or maybe, instead of counting sheep, you like to fall asleep by drifting into the vastness of the universe. Either way, we're about to set out on a quiet journey together. All you need to do is relax. Let your mind loosen, slow your breathing, and allow your body to soften as if gravity itself has faded away. Tonight is not about watching the stars from a distance. We are going to drift inside the Milky Way itself, a colossal spiral of stars, dust, and dark matter that has been turning gently through space for more than 13 billion years. Beautiful from afar, yet filled with secrets beneath its glow. Within this vast structure, stars wander, invisible forces shape motion, and ancient remnants quietly overturn what we think we know. From sweeping spiral arms to a mysterious core, from colossal collisions to stars older than the galaxy itself, we will move slowly, letting each idea unfold without hurry. Along the way, you'll hear about black holes, stellar nurseries, and the strange, unfinished story of a galaxy that is still growing, still changing, still becoming. What you hear tonight may surprise you, or it may simply plant a faint sense of curiosity as sleep approaches. Before we continue, one small request. If these calm explorations help you relax or make it easier to drift off, you can like the video and subscribe to the channel. It quietly helps others find their way here too, one by one, along with sleep. Now, let's begin. Although the Milky Way may feel like a stable, orderly home, its past tells a very different story. It has already collided with other galaxies, and it will collide again. Over billions of years, the Milky Way has swallowed, stretched, and torn apart smaller galaxies, scattering their stars into tidal streams that now wrap around its disk. The Sagittarius dwarf galaxy, for example, is being dismantled even now. And far beyond our skies, Andromeda is slowly approaching. In about 4.5 billion years, the two great spirals will merge in a vast cosmic encounter. Stars will rarely collide directly, but the shapes of both galaxies will be transformed forever, settling into a wide, quiet, new form. Even galaxies are not permanent. They evolve, collide, and begin again. When we look at the Milky Way, it's easy to assume all its stars were born together, but that isn't true. Some stars within it are older than the galaxy itself. These ancient halo stars are metal poor and travel on long, tilted orbits, as if they formed before the Milky Way had fully taken shape. Scientists believe many were born in small, primitive galaxies that merged with ours billions of years ago. Their chemical fingerprints show almost no heavy elements, meaning they emerged shortly after the Big Bang. They move slowly, wandering far above the galactic plane. Like old, imposing spirits from a time before spirals, before structure itself. In their light, we glimpse a younger, wilder universe, still learning what it could become. While the galaxy may feel vast and still, our own solar system is anything but stationary. It races around the Milky Way's center at about 828,000 kilometers per hour. That's more than 230 kilometers per second. Even at that speed, a single orbit takes roughly 225 million years, a span known as a galactic year. Since the solar system formed, we've completed only about 20 of them. When the first dinosaurs walked the Earth, our planet was located in a completely different region of the galaxy. The stars we see tonight were not always our neighbors, and they won't remain so forever. Everything is in motion quietly, slowly, endlessly. Even as you rest, Earth turns, the moon moves, and the entire solar system glides through a living galaxy. Despite its age, the Milky Way is not a finished structure. It is still growing. Even now, it continues to gather matter, gas from intergalactic space, stars from captured dwarf galaxies, and streams of dark matter feeding its halo. It doesn't grow like a living organism, but like a gravitational structure that deepens over time. Some of this growth happens silently, as clouds accumulate. At other times, it arrives with disruption, when satellite galaxies are torn apart and their stars spill across the sky. The galaxy you inhabit today is not the one the dinosaurs saw, and the galaxy future generations will know may be larger still. You might expect astronomers to know exactly how many spiral arms our galaxy has, but even that remains uncertain. From our position deep inside the disk, dust clouds block our view of the far reaches. Stars blur together. For decades, scientists believed there were 4 main spiral arms. More recent observations suggest there may be fewer, or that the arms split, bend, and twist in ways far more complex than once thought. The Milky Way may not be a neat disk at all, but a layered, living vortex shaped by forces we are still trying to understand. Most stars drift calmly through the galaxy, but a few experience far more dramatic fates. Some are violently expelled from the Milky Way entirely. These hypervelocity stars are launched at extraordinary speeds, often after close encounters with the supermassive black hole at the galaxy's center. In a disrupted binary system, one star falls inward and disappears, while the other is flung outward, hurled into darkness at over 1 million kilometers per hour. These lone travelers roam far from the galactic plane, solitary like comets with no return. They remind us that even in galaxies ruled by gravity, escape is possible. Far beyond our immediate surroundings, another massive galaxy is quietly closing the distance. The Milky Way and Andromeda are already on a collision course. Andromeda appears as a faint smudge to the naked eye, more than 2 million light-years away, yet it is steadily moving toward us. In about 4.5 billion years, the two galaxies will merge. The event will be slow, not violent. Stars are too far apart to crash directly into one another, but gravity will stretch both galaxies into sweeping arcs. Tidal tails will unfurl. Black holes may spiral together. Over billions of years, the pair will become one larger system, a slow, graceful dance that writes the future of our cosmic home. Not all stars follow the same orderly paths around the galactic center. Some move against the flow itself. These stars, especially those in the outer halo, orbit in the opposite direction of the galaxy's main rotation. They likely originated elsewhere, born in dwarf galaxies later consumed by the Milky Way. Their reversed motion is a quiet signature of foreign origins, as if their paths carry ancient memories. Stories of long-forgotten mergers are preserved not in light, but in the patient motion of stars moving against the current. Over its lifetime, the Milky Way did not grow in isolation. It grew by consuming others. Dozens of small galaxies were drawn close, captured by gravity, and slowly torn apart. Their remains now form parts of the halo, the disk, and long stellar streams. By studying stellar motion and composition, scientists have identified several past mergers. One of the most significant, the Gaia-Enceladus event, may have reshaped the galaxy's early structure. The Milky Way is not pristine. It is a composite, assembled from quiet collisions and the remnants of many lost worlds. Every star carries a record of its origin written into its very makeup. Chemistry reveals where a star was born. Each star has a unique elemental fingerprint imprinted at birth. Some are rich in heavy elements, formed in dense, metal-rich regions. Others consist almost entirely of hydrogen and helium, born when the universe was still young. These signatures allow scientists to group stars into families, uncover ancient mergers, and reconstruct the Milky Way's hidden past. In this way, chemistry becomes a time machine, letting us read a star's history like an old poem written in light. If we look carefully, the sky itself reveals scars from these ancient events. It is threaded with stellar streams from shattered galaxies. Thin ribbons of stars arc across the sky, faint but unmistakable when mapped precisely. These streams are the remains of smaller galaxies torn apart by tidal forces. As they orbited, their stars were stretched into long, delicate trails that trace their former paths. Some wrap around the galaxy like ghostly halos, others plunge toward the core. Together, they stand as quiet evidence of the collisions that built the Milky Way. Like a tree, the galaxy carries the marks of its past within its structure. Even the shape of the Milky Way itself is less stable than it appears. The galaxy is subtly warped. One side of the disk bends upward, the other downward, forming a gentle wave among the stars. This distortion went unnoticed until radio telescopes mapped hydrogen gas across the galaxy. Scientists believe the warp may be caused by satellite galaxies tugging at the edges, or by unseen clumps of dark matter. Like a vast sheet rippling in slow motion, it shows that galaxies are never truly still. Over time, they bend, stretch, and respond to invisible forces. From afar, you might imagine the Milky Way quietly dancing through space. With the naked eye, you can see only about 0.00003% of the Milky Way. Under a truly dark sky, far from city lights, you might pick out a few thousand stars. It feels like an ocean of light, vast and overwhelming. Yet it is only a tiny droplet. The Milky Way contains more than 100 billion stars. Most remain hidden. Some lie behind thick curtains of dust. Others are too faint or too distant. That pale band stretching across moonless nights is not the galaxy itself, but a faint whisper of a colossal river of stars. We live inside this sea of light, yet we see almost none of it. Movement inside the galaxy is far less orderly than it might seem. Stars do not circle the Milky Way in neat planetary paths. Instead, they move with surprising freedom. In the inner regions, some race ahead, while farther out, others drift slowly. This difference in speed gives rise to spiral arms. They are not solid structures, but patterns like cosmic traffic jams, regions where stars and gas briefly crowd together. As these density waves pass through, new stars are born, lighting the arms with blue-white brilliance. Even our sun moves in and out of these patterns. The galaxy is not a clockwork mechanism. It is a flowing river, and we are carried within it. At first glance, the Milky Way should not be able to hold itself together. By all visible calculations, it should have torn itself apart long ago. Its outer regions rotate too fast, yet the galaxy remains intact. The answer lies in dark matter. It emits no light and reflects none, yet its gravity is immense. There is far more of it than all visible matter combined. We do not know what it is, but we know this. Without it, the Milky Way would fly apart. It is like an invisible skeleton, silently holding everything in place. At the very center of the Milky Way lies something both powerful and unseen. A supermassive black hole, known as Sagittarius A star, sits at the galaxy's core. It holds more than 4 million times the mass of the Sun, compressed into a region smaller than Mercury's orbit. We cannot see it directly, but we watch nearby stars whip around it at astonishing speeds. Occasionally, gas and dust fall inward, flaring in X-rays as they spiral closer. It is quiet now, but in the past, it may have burned like a beacon, lighting the galaxy from within. It remains the silent conductor at the heart of the Milky Way. The center of our galaxy is not shaped the way one might expect. When astronomers mapped it in detail, they found something surprising. It is not round, but peanut-shaped. From the side, it bulges in the middle and narrows at the ends. This strange structure likely comes from the galaxy's central bar of stars. Slowly rotating, this dense band thickens and swells over time. The heart of the Milky Way is not flat or calm. It is dynamic, restless, and complex. Spiral arms are not built of stars alone. Along these sweeping curves, vast clouds of gas and dust are compressed, giving birth to new stars. These regions are known as stellar nurseries. They are chaotic, bright, and alive with energy. The light of newborn stars illuminates the surrounding clouds, painting the arms in shades of blue and silver. Our sun itself was once born in such a cradle, long before it began its quiet journey through the galaxy. Beyond the bright disk lies something far larger and harder to see. The Milky Way is surrounded by an enormous halo. It contains ancient stars, globular clusters, and vast amounts of dark matter. Much of it is invisible, yet it holds most of the galaxy's mass. Within this halo lie the remnants of past mergers, stars torn from smaller galaxies, lingering like cosmic fossils suspended in space. Among the oldest inhabitants of the Milky Way are its globular clusters. More than 150 of these dense star clusters orbit the galaxy in the halo. Each contains hundreds of thousands of stars packed tightly together. Some are over 12 billion years old, formed before the universe had created many heavy elements. They are time capsules, preserving clues to the galaxy's earliest history. Although ancient, the Milky Way is far from finished. It is still growing. It continues to gather gas, consume smaller galaxies, and draw in streams of dark matter. Sometimes this growth is quiet and gradual. At other times, it arrives with disruption, as satellite galaxies are torn apart and their stars scattered across the sky. The Milky Way, seen by the dinosaurs, was not the same one we see today. And the galaxy future generations will know may be larger still. Most stars drift calmly through space, but a few experience violent departures. Some are hurled outward at extraordinary speeds. These are hypervelocity stars. They are often born when binary star systems are torn apart by the central black hole. One star falls inward and vanishes. The other is flung into darkness at millions of kilometers per hour. These lonely travelers move through intergalactic space, reminding us that even in a system ruled by gravity, escape is possible. Star formation itself has changed over time. In its youth, the Milky Way was far more productive. Dense gas clouds continuously formed new stars. Today, the pace has slowed. Gas still exists, but much of it is too scattered or too weak to collapse. The galaxy has not stopped forming stars. It has simply entered a quieter phase. Like a middle-aged spiral, it still shines, but it no longer rushes. Some stars were already old when the Milky Way was young. The galaxy's disk formed gradually, but certain stars predate it. Most now reside in the halo or the thick disk. They were born while the galaxy was still assembling. These are the elder residents of the Milky Way, silent witnesses to its long and patient formation. A single galactic year is vast beyond human intuition. The Sun takes roughly 225 to 250 million Earth years to complete one orbit around the galaxy's center. This is known as a galactic year. In that time, continents drift, species rise and vanish. We are currently midway through one such orbit. The last time the solar system passed this region, Pangaea was just beginning to break apart, and dinosaurs had not yet appeared. A galactic year is like a slow heartbeat of the universe. Despite its age, the Sun has completed surprisingly few of these journeys. In its 4.6 billion year lifetime, it has orbited the Milky Way only about 20 times. Considering its speed, nearly 830,000 kilometers per hour, that number feels small. But the galaxy is immense, and each orbit takes hundreds of millions of years. We often imagine stars as ancient and static, yet on a galactic scale, our solar system is still young, moving among stars that have traveled far longer paths. We are part of this vast motion, but only at the beginning of the story. The rotation of the Milky Way presents a challenge to classical physics. According to Newtonian mechanics, stars farther from the center should move more slowly, just as outer planets orbit the Sun at lower speeds. But in the Milky Way, outer stars rotate just as fast as those near the core. This defies classical expectations. The explanation again points to dark matter, forming a massive, invisible halo around the galaxy. Without it, the Milky Way would not hold together. With it, the equations finally make sense. Scattered throughout the galaxy are immense reservoirs of raw material. Giant molecular clouds, made mostly of cold hydrogen and dust, stretch across hundreds of light years. Gravity gathers matter within them, laying the foundations for new stars and planets. Some are so dense and dark that they block all visible light, appearing as black patches against the sky. These are the galaxy's hidden wombs, quiet, concealed places where the future begins. Among the most violent events in the galaxy are supernovae. Massive stars end their lives in colossal explosions, briefly outshining entire galaxies. Yet these blasts are not only endings. Their shock waves compress nearby clouds, triggering new star formation. They scatter heavy elements like iron and gold into space. Supernovae are the galaxy's fierce storms, destructive, brilliant, and essential. Much of this activity is hidden behind a veil of dust. The Milky Way is filled with microscopic grains of carbon, silicates, and ice. These clouds block visible light, hiding stars and nebulae. Yet behind this curtain, star formation continues. Infrared telescopes can peer through the dust, revealing stellar nurseries glowing with newborn stars. What looks like darkness is often the beginning of something new. Not every cloud of gas becomes a star. Some remain cold, diffuse, and still. These starless clouds drift silently through the galaxy, held in balance by magnetic fields or low gravity. Perhaps one day they will ignite. Perhaps they will disperse and feed other regions. The galaxy seems to hold its breath, waiting for the right spark. The Milky Way wastes nothing. Stars are not eternal. They are born, burn, and die, returning their material to space. Supernovae scatter heavy elements. Red giants shed their outer layers. Nebulae spread enriched gas across the galaxy. This material cools, condenses, and forms new stars, planets, and eventually life. Every atom in your body has passed through this cycle, born in stars, scattered into space, and reshaped into something new. The galaxy is constantly renewing itself, breathing in and out. Some of the oldest stars in the galaxy are poor in metals. In astronomy, metals mean all elements heavier than helium. The first stars contained none, because such elements did not yet exist. Today, these ancient, faint stars are sought in the galactic halo. Their composition reveals conditions shortly after the Big Bang. They are fossils made of light. Stars do not remain where they are born. Over time, gravity, resonances, and spiral arms cause them to drift. Some are flung outward. Others migrate slowly. Even the Sun is no longer where it began. By tracing stellar paths, we learn that the Milky Way is never still. Our place within the galaxy is unusually fortunate. Just as Earth lies in the Sun's habitable zone, the Milky Way appears to have one as well. The core is too chaotic. The outer edges lack heavy elements. Between them lies a broad, stable band rich in the materials life requires. Earth resides within this region, moving along a quiet orbit. The spiral arms themselves are mesmerizing in motion. They are not fixed structures, but traveling density waves. They compress gas, ignite star formation, then release stars back into the flow. From afar, they seem orderly. From within, they are a constant, shifting current. The Milky Way speaks in more than visible light. It hums with cosmic rays, X-rays, gamma rays, and radio waves. These invisible signals reveal ongoing fires deep within the galaxy. We see only a narrow slice of this spectrum. In truth, the Milky Way is a hidden symphony, resonating across countless frequencies. Finally, looming above and below the galactic center are vast structures of mysterious energy. Enormous gamma-ray bubbles stretch tens of thousands of light-years, glowing in high-energy radiation. Known as the Fermi bubbles, their origin remains uncertain. They may be remnants of ancient eruptions from the central black hole, or echoes of intense star formation. Whatever their cause, they are silent imprints of the Milky Way's past echoes of a history we cannot see, but can still feel. We live on a small spur between the Milky Way's major spiral arms, far from the places that usually steal the spotlight. Our solar system is not located within one of the galaxy's thick, dramatic spiral arms. Instead, we sit slightly off to the side. Between the Sagittarius and Perseus arms lies a smaller, quieter stellar stream known as the Orion Spur. It is neither overly crowded nor especially violent. And perhaps that is precisely why we are here. Far from the galaxy's main cosmic highways, massive supernovae are less frequent, and destructive radiation storms are rarer. This relative calm may have allowed life on Earth to emerge and evolve without constant interruption. From the outside, the galaxy appears bright and dramatic. But within this small, peaceful spur, there was enough quiet for complexity to take root slowly. The Milky Way's center is not shaped the way a simple spiral diagram would suggest. When scientists observe the galactic core in infrared light, they do not see a perfect circle. Instead, a thick, elongated bar of stars stretches across the center, like a glowing bridge pulled tight through the galaxy's heart. This bar rotates slowly, shaping the inner spiral arms through gravity. Such bars are actually common in spiral galaxies. They form as stars in the disk gradually drift inward and pile up along a central axis. Over time, the bar stabilizes, stirring gas, triggering new star formation, and funneling material toward the supermassive black hole at the center. This is not just a visual feature. It is a slow, persistent engine driving the galaxy from within. On larger scales, the Milky Way is part of something far bigger than itself. It does not exist in isolation, but as a member of a collection of more than 50 galaxies known as the Local Group. The two largest members are the Milky Way and Andromeda, each surrounded by their own swarms of satellite galaxies. Scattered among them are smaller dwarf galaxies, faint ellipticals, and systems dominated almost entirely by dark matter with very few stars. The Local Group spans more than 10 million light-years and is held together not by proximity alone, but by gravity. We are part of a family, quiet, loosely spaced, yet bound by invisible threads of shared motion and mutual pull. Despite being spread across immense distances, the galaxies of the Local Group do not drift apart. Instead, many of them are slowly moving toward one another. Gravity holds them like dancers in extreme slow motion, bending their paths over millions of years. Some of the smallest galaxies orbit the Milky Way like moons, stretched into streams, pulled apart, and gradually dissolved. Others move more independently, but still remain trapped within this shared gravitational web. Over time, the group may tighten. Galaxies may merge, fade, or be completely consumed. This is not a static arrangement, but a collection of cosmic islands slowly reshaped by time, inertia, and gravity. From a distance, the Milky Way's disk looks flat and calm, almost serene. But once you look closer, that impression falls apart. The disk is layered. The thin disk, where we live, is rich with young stars, open clusters, and gas that is still actively forming new stars. Everything here is brighter and more dynamic. Above and below it lies the thick disk, home to an older, sparser, more subdued population of stars. These stars contain fewer heavy elements and follow more tilted, irregular orbits. They feel like remnants from the galaxy's youth, traces that never fully settled. The disk is not a single surface, but a structure built from layers of time, stacked like sediment on the floor of a cosmic ocean. Although we cannot see them directly, magnetic fields thread through every part of the Milky Way. They run along the disk, rise into the halo, and seep deep into interstellar space. They are far too weak to notice in daily life, yet on galactic scales, they are decisive. They shape how gas flows, how clouds collapse, and which paths cosmic rays follow. They align with spiral arms, arc above the disk, bend, twist, and form complex loops. Understanding them requires patient measurements and radio telescopes, yet their influence is everywhere. The Milky Way does not only shine with light, it breathes through its magnetic fields. The space between stars is far from empty, despite how it first appears. The interstellar medium is a thin but continuous mixture of gas, dust, and plasma. It spreads through the galaxy like a faint mist. Most of the time it is invisible, but at the right wavelengths, its complexity becomes clear. Delicate filaments, vast bubbles, cavities carved by supernova shocks, and cold, dense regions where stars are born all reveal themselves. Stellar winds leave trails stretching across light years. This emptiness is actually a quiet network that carries the galaxy's evolution. Stars are born here, die here, and leave their marks behind. At every moment, high-energy particles pass through your body without you ever noticing. These are cosmic rays. Most were launched by stars that exploded long ago. They travel at nearly the speed of light, bend through magnetic fields, bounce off gas clouds, and sometimes collide with Earth's atmosphere, creating showers of secondary particles. We are unaware of them, yet they carry stories across the galaxy. Echoes of ancient supernovae, traces of distant explosions, memories of violent stellar cores. Even while you rest, the galaxy continues to speak through invisible radiation. The Milky Way is not the perfectly symmetrical object often shown in diagrams. One side of the disk is slightly thicker than the other. Some spiral arms are brighter, longer, or more complex. The outer disk is subtly warped. Even the number of stars is not evenly distributed in every direction. These imbalances are scars left by past collisions, mergers, and the influence of dark matter. Galaxies, like living things, carry their histories in their shapes. These imperfections are not flaws, but memories. Within the galactic halo wander stars that may be almost as old as the universe itself. Some contain almost no heavy elements at all. This suggests they formed shortly after the Big Bang, before the universe had been chemically enriched. They are likely more than 13 billion years old. Born before the Milky Way was fully assembled, they still glow faintly today. They are not just stars, but living time capsules from the universe's earliest era. Stars closer to the galaxy's center move far faster than those in the outer regions. As gravity intensifies toward the core, stars follow tighter, quicker orbits. Some complete a full revolution in just a few million years. Out in the galactic suburbs where we reside, a single orbit takes hundreds of millions of years. This difference in speed creates tension within the disk, stretches spiral arms, and prevents the galaxy from behaving like a solid object. The Milky Way rotates, but not like a flawless machine. It behaves more like a structure that slowly flexes under time. Spiral arms are not permanent strings of stars frozen in place. They are temporary patterns created by density waves moving through the disk. As gas and dust pass through these waves, they compress, triggering the birth of new stars. These young stars light up the arms. Over time, they drift away, replaced by others. That is why the arms seem persistent. Like waves on a lake or traffic jams on a highway, the pattern remains while its contents constantly change. Stars are born hidden in darkness, inside cold clouds of gas. Giant molecular hydrogen clouds drift through the galaxy. Their temperatures hover just above absolute zero. Within them, gravity works slowly. Small regions grow denser, collapse, spin, and form protostars at their centers. Pressure and temperature rise, nuclear fusion ignites, and a new star begins to shine. From the darkest shadows emerge the brightest lights. Many stars are not born alone. They begin life in clusters formed from the same cloud. These groups can remain together for millions of years. But the galaxy is not gentle. Tidal forces, close encounters, and internal motions gradually tear clusters apart. Stars drift away and continue on their own paths. Our Sun was likely born in such a cluster. Its siblings are now scattered across the galaxy. Some have already burned out. Some have been flung far away, and others are lost among the crowd. Among the Milky Way's rarest treasures are hyper-metal-poor stars that have survived almost unchanged to the present day. Their atmospheres contain vanishingly small amounts of elements heavier than helium. Some have less than 100,000th of the Sun's iron. These stars formed just after the first supernovae, when the universe had barely begun to write its own chemistry. They are incredibly old, pristine, and scattered throughout the halo. Each one is a silent signature from the dawn of time. Planets are not an exception in the universe, but a natural outcome of star formation. When a star is born, a rotating disk of gas and dust forms around it. Within this disk, particles collide, stick, grow, and eventually become worlds. Planetary systems are common throughout the Milky Way, some packed with giant gas planets, others crowded with small rocky worlds. Some resemble our own system, while others defy every expectation. The galaxy is not made of stars alone, but of countless families of suns. Within the Milky Way, spiral arms rotate at a different speed than individual stars, yet there exists a special balance point. At a certain distance from the center lies the corotation radius, where the average orbital speed of stars matches the rotation speed of the spiral arms. Our Sun orbits near this boundary. This resonance may have kept us away from dense stellar regions and frequent supernova explosions. We live in a calmer neighborhood, protected not by walls, but by orbital harmony. As the Sun travels around the Milky Way, it does not follow a flat path. Over tens of millions of years, it rises above the galactic plane, then sinks below it, oscillating like a slow-motion wave. This motion is caused by the gravity of the galaxy's total mass. Some scientists have wondered whether these oscillations influence mass extinction cycles on Earth. The evidence is inconclusive, but one thing is clear: the Sun is not fixed. It gently sways through space. Most of the Milky Way's mass does not come from what we can see. It is dominated by dark matter. Dark matter emits no light, absorbs none, and passes through ordinary matter, yet its gravitational influence is undeniable. It explains the unexpected speeds of stars and prevents the galaxy from flying apart. Astronomers cannot observe it directly. They infer its presence from how other objects move. Dark matter is the galaxy's invisible scaffolding, silent, mysterious, and still unresolved. While most of the glowing stars lie in the galactic disk, most of the mass lies beyond it. The Milky Way is embedded in a vast halo of dark matter that extends far beyond the disk and is sparsely populated by ancient stars and globular clusters. We imagine spiral arms, but that is only the surface. The true mass is unseen, wrapping everything in a quiet, invisible shroud. Today, the center of the galaxy appears calm and subdued, but this quiet surface hides a far more violent past. The Fermi bubbles and traces of high-energy radiation reveal that the supermassive black hole at the core once passed through a quasar-like phase. Quasars are among the brightest objects in the universe. If the Milky Way once shone like this, It must have appeared as a spiral, with a heart blazing with light. That era has long passed, but its echoes still linger. Galaxies may seem timeless, but in reality, they are always changing. Spiral arms shift, bar structures form and dissolve, gas flows reverse direction. Stars are born, die, and leave behind subtle traces. Even the Milky Way's disk is not flat. It is warped, rippled, and constantly evolving. Encounters with dwarf galaxies bend and disturb this structure. The Milky Way we see today is not the one that existed in the past, nor the one that will exist in the future. Its beauty lies not in permanence, but in transformation. Across the universe, colossal collisions unfold on scales beyond imagination. Black holes merge, neutron stars collide. These events generate gravitational waves that ripple through the fabric of space-time itself. Some of those waves pass through the Milky Way, gently stretching and compressing space almost imperceptibly. LIGO and Virgo have already detected several of them. Even now, as you remain still, space itself is quietly changing. Not all stars follow neat, circular paths around the galactic center. Some travel on long, elliptical orbits, tilted at steep angles. Many come from elsewhere, remnants of swallowed dwarf galaxies or relics of the galaxy's turbulent past. Their motions preserve clues about how the Milky Way was assembled. By tracing these orbits, astronomers reconstruct the galaxy's invisible architecture. Every second, trillions of neutrinos pass through your body without leaving a trace. They are born in the sun's core, in supernovae, and in violent cosmic processes. Nearly massless and extraordinarily elusive, they slip through matter almost untouched. Deep underground, enormous detectors wait patiently for the rare moment when one interacts. Neutrinos are silent messengers of hidden energy. The space between stars is not empty, but restless and alive. Clouds of gas and dust are constantly stirred by shock waves, magnetic fields, and stellar motion. Temperatures rise and fall, clouds stretch and fragment. On large scales, this environment resembles a slow-moving ocean. Star formation and galactic evolution are shaped by this uneasy sea. Planets do not always remain bound to their stars. Some are ejected from their birth systems. Others may form without a star at all. These rogue planets drift alone through the galaxy. Their numbers may reach into the billions. Without starlight or external warmth, they persist on internal heat alone. Silent nomads, wandering the dark between stars. Interstellar dust does not merely respond to gravity, it is sculpted by the galaxy's magnetic fields. Invisible currents guide gas and dust like unseen rivers. In some regions, dust spins and emits microwave radiation. In others, it polarizes incoming light. Dust is not passive debris. It traces hidden patterns in the dark, dancing to a magnetic rhythm. In certain regions of the Milky Way, enormous spherical shells of gas stretch across hundreds of light years. These structures are not accidental. Once, massive star clusters formed here and ended their short, violent lives in successive explosions. Stellar winds and supernovae tore through the interstellar medium, carving vast cavities and flinging gas outward. Over time, the expansion slowed and the energy faded, but the shells remained. These ghostly bubbles quietly remember how active and fiery the galaxy once was. Cool fossils of cosmic fireworks whose echoes still persist. Space often appears empty, with stars small and distances unimaginably vast. Yet, in extremely crowded regions such as the cores of globular clusters, this illusion breaks down. Stars pass dangerously close to one another and, on rare occasions, collide. The outcomes are unusual. Sudden flares, stellar mergers, or blue stragglers that appear younger than their surroundings. These events are uncommon, but not impossible. Over billions of years, such dense stellar neighborhoods continually reshape themselves through gravity and chance. In these places, space is never truly quiet. Many stars spend their lives bound to a companion, but such partnerships are not guaranteed to last. When a binary system ventures too close to the galactic center, a supermassive black hole, or an exceptionally dense cluster, tidal forces disrupt their orbits. Sometimes, one star is hurled outward at tremendous speed, while the other is captured or slowed. In rare cases, a star is torn completely free and flung into intergalactic space. These separations are not dramatic. They are sudden, silent, and final. Old partnerships ended by gravity's indifferent force. Most stars remain gravitationally bound to the Milky Way, but on rare occasions, one gains an extraordinary velocity. Speeds exceeding 500 kilometers per second mark a point of no return. Hypervelocity stars are real. Some result from close encounters with the central black hole, others from three-body interactions or supernova explosions in binary systems. Once freed, they travel alone toward intergalactic space, like small lighthouses carried far beyond the spiral. Pilgrims walking into the dark, carrying the galaxy's history outward. Not every star in the Milky Way was born here. Some were captured during past mergers. Others were flung into the halo from distant corners of the local group. These stars usually occupy unusual orbits far from the disk. They reveal themselves through their motion or chemical composition, never quite blending in. They are cosmic migrants, carrying traces of other skies and other histories. The Milky Way is not a closed system, but a living mosaic, continually assembled and reshaped. Above and below the bright disk, gas moves in a slow, continuous cycle known as the galactic fountain. Supernovae and stellar winds heat material and launch it into the halo. There, the gas cools, condenses, and over millions of years drifts back down into the disk. This circulation stirs the environment, spreads heavy elements, and influences where and when new stars form. The galaxy does not only rotate, it breathes. Dust clouds drifting between stars carry complex organic molecules, the basic ingredients of life. Polycyclic aromatic hydrocarbons, simple sugars, alcohols. They are not alive, but they are chemically rich. Formed in dying stars or deep within cold clouds, they are carried across light years by galactic winds. These particles mix into stars and planets. Some may even have reached the young Earth. Galactic dust is not merely debris, it is possibility in motion. The places where stars are born are also where planets begin. As planetary systems form, they inherit the chemical fingerprints of their parent clouds. If those clouds contain water, carbon, and complex molecules, these materials can be delivered to planetary surfaces by comets and asteroids. Certain regions of the Milky Way are especially rich in this respect. We do not know how common life is, but we see that the conditions for it arise naturally. Most stars rotate, but a few spin at astonishing speeds. Some complete a full rotation in just a few hours. These stars are usually young, massive, and unstable. As they spin, their equators bulge and sometimes shed material. While the sun rotates once every 25 to 35 days, these stars push against their physical limits. Their lives may be short, but while they spin, they shine like sirens in the dark. We see the Milky Way in the sky as a hazy band of light, but this band is not aligned with the plane of the solar system. The galactic disk is tilted about 60 degrees relative to the ecliptic, causing it to shift across the sky throughout the year. We are inside the galaxy, but at a slight angle, like a small, tilted boat drifting through a vast sea of stars. Within the halo lie stellar remnants older than the disk itself. White dwarfs, formed when the galaxy had not yet taken its full shape, have been cooling and fading for billions of years. The disk may shine brightly, but the galaxy's oldest memories are stored in the halo. The most distant stars of the Milky Way wander far beyond the spiral arms, hundreds of thousands of light-years away. Within the halo, they follow wide, slow orbits that can take billions of years to complete. Many are remnants of ancient mergers. They are faint but crucial, defining the true size of the galaxy. The Milky Way does not possess perfect symmetry. It is often drawn as a neat spiral, but in reality, it is slightly lopsided. One side of the disk is thicker, the arms are uneven, and even the halo is offset from the center. These irregularities are scars from past encounters. The galaxy is not a machine, but a living structure marked by history. Some stars pulse rhythmically, brightening and dimming as if breathing. From this rhythm, their true brightness can be calculated, and their distances measured. They are cosmic rulers, lights that measure the dark. The Gaia mission is mapping the Milky Way in unprecedented detail by measuring the positions and motions of more than 2 billion stars. With each new dataset, the galaxy comes into sharper focus, transforming from a blurred glow into a living structure. On a dark night, the hazy band stretching across the sky marks the densest part of the galaxy. This is more than a beautiful sight. It is a crowded heart where stars are born, live, and die. When two neutron stars spiral around each other and finally collide, one of the most violent events in the universe unfolds. It is brief, but its consequences endure. In this explosion, known as a kilonova, heavy elements such as gold, platinum, and uranium are forged. Matter is torn apart, flung into space, mixed with gas, and millions of years later incorporated into new stars. Some stars in the Milky Way still carry the chemical fingerprints of these catastrophes. They are not merely sources of light, but silent records of ancient collisions and vast destructions. As one moves closer to the galactic center, the structure does not simplify. It becomes more complex. A long stellar bar cuts across the disk from end to end. Deeper in, there are strong indications of a smaller inner bar, tilted at a different angle and rotating almost independently. Dust and distance prevent us from seeing it directly, but the motions of stars betray its presence. These bars funnel gas and dust inward, guiding material toward the central black hole and shaping the fate of the core. The heart of the Milky Way is not a neatly ticking machine, but a tangled labyrinth of light, dust, and motion. The Milky Way is not a self-contained island. It draws in long streams of gas from the intergalactic medium. These flows provide the raw material for new stars. Some drift quietly into the disk, others plunge in hot and luminous. Barely visible, these rivers feed the galaxy and tie it to the larger universe. Even today, the Milky Way continues to grow by tapping distant reservoirs. When massive stars explode, they do more than emit light. They reshape their surroundings. Supernovae carve out enormous cavities. Over time, these merge into vast superbubbles. The disk becomes perforated, allowing hot gas to rise into the halo. These chimneys, carrying energy and heavy elements upward, are like the galaxy's breathing. The Milky Way is not only a flat disk, it also flows upward and outward. In visible light, the galaxy appears calm, but in X-rays, it reveals a very different face. Collapsed stars, black holes, and gas heated to millions of degrees radiate intensely. Telescopes such as Chandra and XMM Newton show the Milky Way as a realm dominated by extreme temperatures and hidden radiation. Beneath the placid surface lies a constant boil of energy. When a massive star collapses into a neutron star, it sometimes keeps spinning with remarkable regularity. From its magnetic poles, it sends narrow beams of radiation into space. Each time those beams sweep past Earth, we receive a pulse. Some pulsars rotate hundreds of times per second. Their stability is so precise that astronomers use them as cosmic clocks. They are remnants of death, yet also beacons of order and precision. Most of the galaxy is hidden in visible light. Radio waves, however, pass through obstacles with ease. They reveal cold gas, magnetic fields, pulsars, and supernova remnants. Spiral arms were mapped this way, and the warp of the disk was measured. The galaxy speaks in a language we cannot hear, and science has slowly learned how to listen. Stars are rarely born alone. The Sun was no exception. It formed from the same gas cloud as hundreds of siblings. Over time, the cluster dispersed, and the stars scattered onto different orbits. Most of those siblings were lost. Some may still be nearby. The Sun appears solitary today, but its past was crowded. Astronomers now search for stars that share the Sun's age and chemical signature. Missions like Gaia are trying to identify these lost relatives. If they are found, we will better understand the conditions under which the Sun was born and the kind of stellar nursery it came from. Somewhere, they may still be shining quietly. The disk of the Milky Way is not a rigid, perfectly flat plate. It gently ripples, with one side bending upward while the other dips down. Nearby dwarf galaxies, dark matter, and past encounters drive these oscillations. From afar, the galaxy would not look flawless. It would resemble a living, breathing sheet of stars. The galaxy's mass does not leave star clusters untouched. Tidal forces gradually stretch them apart, tearing them into long, stellar streams. The faint arcs seen across the sky are remnants of this process. The Milky Way does not rush. It dismantles patiently, thread by thread. Determining the true mass of our galaxy remains difficult. Stars and gas account for only a small fraction. The rest is dominated by invisible dark matter. Estimates vary, from 1 trillion solar masses to even more. The weight of our own home galaxy is still uncertain. For a long time, Andromeda was thought to be heavier. New measurements, however, suggest that the Milky Way's dark matter halo may be denser than expected. If this is correct, the balance in their future merger will differ from what we imagined. The Milky Way may seem quiet, but it is not weak. The Magellanic Clouds in the southern sky were long considered ancient satellites of the Milky Way. New data indicate they may be approaching for the first time. They are likely recent arrivals, caught by the galaxy's gravity. Their passage has stirred the disk, displaced gas, and warped the structure. Trailing behind these clouds is a vast ribbon of hydrogen. Known as the Magellanic Stream, it was torn away by tidal forces and revealed in radio waves. One day, it may fuel new star formation, or it may remain a frozen relic in intergalactic space. Not everything in the Milky Way follows the plane of the disk. Some gas clouds and stars move on tilted, even nearly vertical orbits. These paths are leftovers from past mergers and ancient upheavals. Such misalignments are evidence that the galaxy is still a living, evolving structure. In the night sky, the center of the Milky Way lies in the direction of Sagittarius. It is a dense region packed with stars, dust, and invisible mass. We cannot see its core with the naked eye. Dust blocks the view. In infrared and radio wavelengths, it shines intensely. Even so, to the naked eye, that direction appears brighter and more crowded. We orbit far from the center, in a quiet suburban stretch of the disk, looking inward toward a crowded cosmic city. Because we live inside the galaxy, we can never view it from above. We see it as a hazy band of stars stretching across the horizon. This edge-on perspective compresses the structure and makes it hard to interpret. Understanding the spiral form required centuries of observation and mathematics. It is like standing in a forest and trying to infer its shape from the line of trees around you. Even with the most powerful telescopes, only part of the Milky Way is visible. Light is blocked by dust, motion disappears into silence, and dark matter outweighs the shining stars. Between every star lies emptiness, and within that emptiness, potential. The galaxy is not just what we see, but what we infer, suspect, and struggle to understand. It carries ancient light, future stars, drifting worlds, and unanswered questions. And within this vastness, we exist too, a small planet orbiting a quiet star, suspended inside an immense story. From the warped disk to the most distant halo stars, from newborn suns to dead remnants, this is a single continuum. A narrative moving from dust and gas toward light and shadow, from stellar nurseries to spiral arms, from behind veils of dust to the galactic heart. You are not an external observer of this galaxy. You are part of it. The iron in your blood was forged in stars. The oxygen you breathe was shaped in ancient explosions. Your atoms carry a history that reaches back to the earliest times. Even as you rest, the galaxy keeps turning. Stars are forming, light is traveling, orbits continue in silence. And you are within it, a small warmth in the dark, a temporary glow riding a spiral arm. The galaxy continues to rotate, and now it is time for you to rest. Good night.